All right, so we're on problem 5 of the final exam practice. In this problem, we want to find the centroid of this given region, and we're assuming that this region has uniform density. And so if you remember, once we know that a region has uniform density, then in fact the density of the region is completely irrelevant because it just cancels out of our equations anyways for the x and y coordinate of the centroid. All right, so first and foremost, let's just write down the equations for the x and the y coordinate of our centroid. And so in this case, the x coordinate, well, I mean, this is in general when y is bounded between the x-axis and some positive function. We have that the x coordinate of our centroid is just 1 over the area of this particular region. We'll compute that in a minute. Times this integral from 0 to 2 because those are the bounds on my x. And I am integrating x times f of x dx. Okay, so this is the x coordinate of my centroid. Here is the y coordinate of my centroid. And of course, we know that we're denoting the x coordinate and y coordinate of the centroid with these bars above them. But either way, this is 1 over the area times the integral from 0 to 2, again, because x goes from 0 to 2. And this is 1/2 times my function f of x squared dx, where in this case, for our problem, we're treating the function f of x as 2x minus x squared. Okay, so let's compute this area. Area is pretty easy to compute. We just need to find the integral of this function, right? Because we know that this region, right, is between the values of x 0 and 2. Y goes from the x-axis, and it's basically just everything below the graph of this function. We graphed this in another video, so you can check out that video about volumes. But either way, all we have to do is just take our function and integrate it from 0 to 2 since our function is positive. Okay, so either way, I integrate this function. So the antiderivative of 2x is x squared. Antiderivative of x squared is 1/3 x cubed. Okay, and then I just need to evaluate at 2 and at 0. Of course, I evaluate at 0, and I get 0 for both of my terms, so it contributes nothing. I evaluate at 2, and I'm going to get 4, so 2 squared is 4, minus 2 to the 3 is 8 divided by 3. Right, so this is 12 over 3 minus 8 over 3, so this is 4 over 3. Okay, that's my area, okay, not my centroid. Okay, so I have this A now, so that's good. So now I can go ahead and compute the x coordinate and the y coordinate for my centroid. So this is going to be 3 over 4, right? Because remember, we're doing the reciprocal of the area. The area was 4 over 3, so the reciprocal is 3 over 4. And then we want to compute the integral from 0 to 2 of x times our function f of x. F of x is 2x minus x squared. All right, so let's just distribute this x to each term, and then we'll integrate it. So this is going to be 2x squared minus x cubed dx. And so we want to integrate this function. So 3 over 4 sticks around. So to integrate 2x squared, right, I increase the power, I divide by the new power, so I have 2/3 x to the power 3. And then minus 1/4 x to the power 4. But again, the wonderful thing happens where when we plug in 0, we get nothing, so we really only need to evaluate at 2. So I'll write it down and then I'll just tell you the value. So we get 2 cubed minus 1 over 4, 2 to the power 4. Okay, and that equals... So that equals 1 after plugging all this into our calculator and checking. So we get 1 for the x coordinate, which actually is not unexpected, and I'll show you why in just a second. But let's calculate the y coordinate for our centroid first. So we take the reciprocal of the area, so that's 3 over 4, and then I want to compute the integral from 0 to 2 of the square of our function, times 1/2. Okay, so 2x times x squared, all to the power 2. Okay, so this is going to be 3 over, well, I can take this 1/2 out, so this is 3 over 8, integral from 0 to 2. Let's distribute everything. So we're going to end up with 4x squared minus 4x cubed plus x to the power 4 dx. So that's what we get when we expand this 2x minus x squared to the power 2. And so we get 3 over 8, of course, just hangs out. We now can just take the antiderivative of this expression, 4x squared minus 4x cubed plus x to the power 4. So we're going to get 4 over 3 x cubed for the first term. We're going to get minus x to the power 4 for the second term, and then plus 1/5 x to the power 5 for the third term. And we need to evaluate at 0 and 2. And of course, the value at 0 is just 0, so we'll only need to evaluate at 2. All right, so evaluating at 2, we'll just write it out at first. So this is 3 over 8 times 4 over 3 times 2 cubed minus 2 to the power 4 plus 1/5 2 to the power 5. And then evaluating this number to get something reasonable, we get 2 over 5. Okay, so this is the y-coordinate for our centroid, and we calculated the x-coordinate earlier. So our centroid has coordinates x bar comma y bar, and so in this case it's 1 comma 2 over 5. And so I mentioned, sorry about that. I mentioned that we could have seen that the x-coordinate for the centroid was equal to 1 from the beginning, and this is because of the symmetry principle. So let me kind of illustrate that argument. So our region looks like this. So here's x comma y. So we have a 0 for our function 2x minus x squared. So 2x minus x squared. For this to be equal to 0, I can factor it into x and 2 minus x. So of course it'll be equal to 0 for x equals 0, and also for x equals 2. Okay, and this is our parabola here. So this is our region that we've been computing the centroid of and everything. And one thing that we notice about this parabola is that it has an axis of symmetry at x equals 1. So how do I know that? Well, because I know that the zeros of a parabola are going to occur at the same distance away from the axis of symmetry. So what I'm saying is that this distance and this distance, so from the 0 to the axis of symmetry, from the axis of symmetry to the other 0, those distances are the same. And in fact, they're equal to 1 here, right? Because we have a total distance of 2, and we need to make the distance from 1, 0 to the axis of symmetry just half of that distance, so that's 1 in this case. So this is the line x equals 1. And since our region is symmetric with respect to this line, x equals 1, we know from the symmetry principle